Welcome to the video on how to write your lab report for Experiment 6, Percent Composition. Let's begin with writing the chemical reactions that were carried out in this lab. In Part A of this lab, potassium chlorate was decomposed by heating the compound at high temperature. We used proper lab techniques to carry out the decomposition reaction such that we could determine the percent composition of oxygen in potassium chlorate quantitatively. This reaction can be described with the use of a word equation. Solid potassium chlorate and heat produce solid potassium chloride and oxygen gas. Solid potassium chlorate is the reactant. It must be heated to high temperature in order to produce the products solid potassium chloride and oxygen gas. Since heat is required for this reaction to take place, heat is written on the reactant side. The balanced chemical reaction is exactly as written. The triangle over the arrow means that heat is added to the reaction. When copying the balanced chemical reaction into your lab report, pay close attention to the use of subscripts for the chemical formulas and brackets to indicate the physical state of each compound. In Part B of this lab, an aqueous solution of potassium chloride reacts with a silver nitrate solution. Nitric acid is written over the arrow to indicate that a few drops of nitric acid is added to the reaction to acidify the solution. The products of the reaction are solid silver chloride and a solution of potassium nitrate. Silver chloride is the precipitate which causes the solution to become cloudy. Note that there is an asterisk next to the potassium chloride in this word equation. The asterisk indicates that the residue in Part C will be substituted for the potassium chloride as a test. This is to see if the residue will behave similarly as the potassium chloride in this reaction. The balanced chemical reaction is exactly as written. When copying the balanced chemical reaction into your lab report, pay close attention to the use of subscripts for the chemical formulas and brackets to indicate the physical state of each compound. In the lab, a demonstration involving a gummy bear was given. Do you remember the gummy bear demonstration? Please review the video, The Spontaneous Combustion of a Gummy Bear. Let's go through the data and calculations for Part A, Decomposition of Potassium Chlorate Reaction. Item 1 shows that the mass of the empty crucible used is 17.1557 grams. A certain amount of potassium chlorate is used in the reaction. Item 2 shows that the combined mass of the crucible and potassium chlorate is 19.5967 grams. To calculate the mass of the potassium chlorate used, Item 1 is subtracted from Item 2. Item 5 shows that the mass of potassium chlorate used in the reaction is 2.4410 grams. The potassium chlorate starts out as a white powder. Upon heating, bubbling occurs. After the first heating, a residue remains in the crucible. The residue is a transparent, glassy solid. Item 3 shows that the mass of the crucible and the residue after the first heating is 18.5869 grams. To ensure that the potassium chlorate is completely decomposed, a second heating is carried out. Item 4 shows that the mass of the crucible and residue after the reheating is 18.5848 grams. Note that there is a slight difference in mass after the first and second heating. The difference is measurable and is observed in the third decimal place. As a result, the mass of the second heating is used in the calculation of the mass of the residue which remains. To calculate the mass of the residue, Item 1 is subtracted from Item 4. Item 6 shows that the mass of the residue is 1.4291 grams. The difference in mass between Item 5, which is the mass of the potassium chlorate used, and Item 6, which is the mass of the residue after the heatings, must be the mass of the oxygen that was released from the potassium chlorate as a gas. Item 7 shows that the mass of the oxygen released is 1.0119 grams. Let's use these raw data to calculate the experimental determination of the percent of oxygen in potassium chlorate. The percent of oxygen in potassium chlorate is equal to the mass of oxygen divided by the mass of the potassium chlorate multiplied by 100. Look up the mass of oxygen in the data table. It is item 7, 1.0119 grams. Look up the mass of potassium chlorate in the data table. It is item 5, 2.4410 grams. Use your calculator to perform the calculation. Be sure to apply the significant figures rules for division and rounding to arrive at the answer. The answer is 41.454%. It has 5 significant figures. Please review the video on significant figures, multiplication and division rule, and the video on significant figures, rounding rule. The theoretical percent of oxygen in potassium chlorate can be calculated by using the atomic mass of oxygen and the molar mass of potassium chlorate. The formula for the percent of oxygen is equal to 3 times the atomic mass of oxygen divided by the molar mass of potassium chlorate multiplied by 100. We need to multiply the atomic mass of oxygen by 3 because there are 3 moles of oxygen per mole of potassium chlorate. The periodic table of elements gives the mass of 1 mole of oxygen to be 15.999 grams per mole. The molar mass of potassium chlorate can be calculated by adding the molar masses of 1 mole potassium, 1 mole chlorine, and 3 moles oxygen. This gives the molar mass of potassium chlorate to be 122.55 grams per mole. Using these given masses, the answer to this calculation has 5 significant figures. Make sure that the theoretical calculation of the percent of oxygen in potassium chlorate contains as many significant figures as the experimental determination of the percent of oxygen in potassium chlorate. Please review the video on significant figures, multiplication and division rule. The percent error calculation can be carried out using this formula as shown. For the theoretical percent of oxygen in potassium chlorate, please consult slide 7. For the experimental percent of oxygen in potassium chlorate, please consult slide 6. Show your work in the space provided and report your answer with the proper number of significant figures. Please review the video on how to write experiment 3, weighing and density measurements for a sample calculation of percent error. Let's look at the lab questions. Question 1. In part A, what would be the effect of insufficient heating on your experimental result? Would the experimentally determined percent of oxygen in potassium chlorate be higher or lower than the theoretical prediction? Let's look at our data. Insufficient heating would make item 4, the mass of the crucible and residue after reheating, bigger. As a result, item 6, the mass of residue which remains will also become bigger. What would this do to the mass of the oxygen released? Will it become bigger or smaller? Let's think this through. If the mass of the oxygen released is bigger, then the percent of oxygen in potassium chlorate will be higher. If the mass of the oxygen released is smaller, then the percent of oxygen in potassium chlorate will be lower. Question 2. In part B and part C, which 2 test tubes behave similarly, and what can be concluded about the residue as a result of the comparison of the 3 test tubes? The photo on the left shows 3 test tubes of 3 different substances dissolved in water. The residue which remained from the decomposition of potassium chlorate, pure potassium chlorate, and pure potassium chloride. The photo on the right shows the same 3 test tubes after nitric acid and silver nitrate have been added. Inspect the test tubes. Does the test tube with the residue resemble the test tube with the pure potassium chlorate, or does it resemble the test tube with the potassium chloride? By carrying out a comparison of these reactions, it allows us to conclude the identity of the residue. Question 3. Write the balanced chemical equation with the correct states and word equation for the chemical reactions which occurred in Part A and Part C. To answer this question, refer to slides 3 and 4 and copy the balanced chemical equation and word equation exactly. Question 4. Calcium chlorate, when heated, also releases oxygen. The residue which remains is calcium chloride. Write the word equation for this reaction and include the physical states of each of the reactant and products. The decomposition of calcium chlorate proceeds similarly to the decomposition of potassium chlorate. To answer this question, refer to slide 3 and write the word equation for the decomposition of calcium chlorate. Let's look at how to write the conclusion for experiment 6. In the first paragraph, use the following keywords in 2 sentences: decomposition reaction, residue, Fischer burner, endothermic. In the second paragraph, include by copying the 2 chemical reactions carried out in part A and B. Pay attention to subscripts. Consult slides 3 and 4 and copy the word equations for each reaction into your conclusion. In the third paragraph, summarize the observations in part B. State the identity of the residue and the evidence used to identify the identity of the residue. Consider using a table as shown to summarize your results. In the fourth paragraph, summarize the percent of oxygen in potassium chlorate, the theoretical calculation, and the experimental result. Report the percent error. Consider using a table as shown to summarize your results. Watch your significant figures when numbers are being reported. Based on your percent error, comment on the heating technique used to decompose the potassium chlorate, i.e., how many types of heating were used and how long were the heatings. Thank you for watching this video on how to write your lab report for experiment 6, percent composition.